In the name of God. Hello guys, today I'm gonna teach locating new equip. As you can see here, we have this equip 1 and equip 2 and 3, and we want to locate new equip among them. So the first I want to introduce some things here. A P1 means we have A1 and AB and B1, which means the coordinates of point equip 1. We have M, which means number of existing equips. We have X with this X and Y, which means the coordinates of a new equip that we want to calculate it, the optimal coordinate for this new equip. And we have W for I, means the cost of moving materials between new equip and existing equip I per meter. And we have D with X and P for I, which means the distance between new equip and the existing equip, which we want to show it with I. We want to show it with I. So we have F for X, which means the cost of establishment of new equip. And we have this objective function. We want to minimize the cost of establishing new equip among existing equips. Here I want to talk about the way we want to calculate distance between new equip and existing equips, which we you see here want to calculate it with the stairs distance. It's like this, it's like a stairs. So the distance between new equip and, for example, existing equip I is this statement, for X axis and Y axis. So this function, this objective function, we want to minimize the costs. We show it like this. This statement, this one is the cost of, the cost of moving material, or the cost of, is to calculate the cost of the distance we have between new equip and existing equip I, and we have to sum this cost for all the existing equips. So we have this statement here, means equip I to equip M, every equip that we have. So we have this one, we separated these two statements. This is one method, which is median method. This is an example, and I want to learn this method with an example. P1, P2, P3, and P4, these are our existing equips, and these are its coordinates. for each equip. And the way to calculate the best point or optimal x-axis for new equip is to calculate this term, which means first we have to calculate all these cost of the distances between the cost of the moving between our new equip and our exiting equip I. So we have to calculate all these costs per meters and then divide it to 2. And we have to calculate the cumulative sum of weights from the first equip to the J equip, and then we have to, if we see this statement, we have to continue and compare the next J. But if we reach to this point, for example, when we reach at J3, we compared this statement and this statement, and we see that yes, this is greater than this part. So we have to stop and we have to say that J is the third exiting equip, and its x-axis is the optimal x-axis for our new equip. But in the next here I want to mention something important. When we want to calculate the optimal x-axis for new equip, first of all we have to sort all these existing equips with their x-axes. As you can see in here, we don't care about the number of equipment. We have 1 and then 3 and then 2 and then 4, but these x-axes are sort 1 2 3 6 in this way. And we have the weights, it's 3 2 1 4 5, and it's not important for us if these weights are not are not sorted actually from the lower one to higher one, but we have to sort the equipments by their x-axis from the smallest one to the biggest one. So we have these weights here, and we calculated this number, and it's 5.5. and here actually when we sum these ones, we have 3, and then we have 5, because it's cumulative. actually we have 3, and when we sum 3 and 2 it's 5, and we sum 3 to 1 it's 6, and actually this one, actually this weight, and actually this equip, which is equip 2, and its x-axis 3 is our optimal x. And we do the same thing for y-axis. Here, ascending order by by y-axis, 1, 2, 5, and 7, and we write it their weights, and we do the cumulative sum of weights, and actually this number is 5.5, and we reach it at this one. I'm sorry, this is wrong, this 5 is wrong, it's actually 2, because we reach to more than 5.5 at 8, so the equip 1 and its y-axis is our optimal y for our new equipment. Thank you so much to watch my video, and I hope I can make the future videos for you.